Today we'll be talking about mutations and their effect on protein translation. So here's our reference DNA sequence, and then these are the mRNA transcripts that we can get from it. So this one came from the bottom strand, and this one came from the top strand. And so because we're using our amino acid sequence from this mRNA transcript from the top strand, the bottom strand of DNA is going to be our coding sequence. Okay, so a read-through mutation occurs when there is a change in the stop codon that turns it into an amino acid, and so the ribosome keeps translating proteins downstream of where it initially should have stopped. And this, by the way, was an A to a C mutation, so that's going to be a transversion. Alright, and that looks like this is our normal amino acid sequence, right? And then this would be our much longer mutated amino acid sequence. Alright? And the ribosome will keep translating proteins until it hits another stop codon. So a silent mutation is when there is a mutation in a coding sequence, but it has no effect on the amino acid that codon should have made. So we can see here we changed a C to a T, which was a transition, but it had absolutely no effect, and we still had valine at the end of the day. So you can think of that as, originally we had this cup, and then somehow inside the molecules of the cup, something got switched, but it didn't matter because at the end of the day, we still have this cup. So a nonsense mutation is going to occur, and it's going to change an amino acid into a stop codon. So we can see here we changed an A to a T, which was a transversion, and that gave us a stop codon here. Initially, our stop codon was here. So this means we're going to have a much shorter and most likely non-functional protein. So what that looks like is here, originally, here's our amino acid sequence, and then it got cut, and now it's shorter and ineffective. So the final mutation we'll talk about is a missense mutation. So this could look like A mutating into C, which was a transversion, and then because of that, our codon now codes for arginine instead of serine. So a missense mutation is when it changes the amino acid that a codon should code for. Alright, so what does this mean for the protein? Well, it could be beneficial and make the protein more effective, or it could be problematic and make the protein less effective or completely ineffective. So you could think of it as my phone is a computer and it computes decently well, but my laptop is mutated and is a much better, faster functioning computer.